My name is Wojciech Rosikiewicz, and today I'm going to show you how to use one of the features of CovidExpress portal, that is DEG, so identification of differentially expressed genes. So starting from the landing page of CovidExpress, if you click here on this CovidExpress server link, the main one, this will redirect you to the page, interactive page that you probably are already familiar with, to some degree at least. And let's just put some name. It's not that important, but let's just keep it DEG for now. And I'm going to show you the method of how to select samples using this left side navigation bar. Let's put it that way. So in CovidExpress we have over 40 different experiments included. And we can color them by samples from them by different colors, and as you can see, like that, all of these samples are from mostly one. Here we have maybe 2, 3 different experiments, and in if you remember from the paper, we strongly advise not to mix the samples for differential contrasts between experiments. So that is why I really like to use this left hand side option, this menu, to select samples from only particular one experiment. As you can see here, they highlight. So for the purpose of this demonstration, I will use this GSE 157103, which is 126 samples highlighted in yellow. So let's just put it here. So 126 samples, but one could actually ask, what are those samples? And there's a way to, like when we have it, this GSE number, if we want to quickly find it out, then let's just go back to the landing page. If you scroll down a little bit, here, yes. So there is a part called Metadata Explorer. So if you click this Open Explorer page, it will redirect you to the interactive table where you can view all of the 1000 samples metadata. And there is a custom search builder. So let's just use it to select experiment. So this is this field. As you can see, these are GEO numbers, accession numbers. Let's put it at equals. And now let's find this, that was 157103. So this one. So yes, it shows 126 entries. So 126 samples are included here. Let's just change the view to show it all. As you can see, there are all of these samples, and yeah, these are the tissues. From this we can use read that, and they are all COVID or other. So I will get back to this in a second. So we have COVID, we have tissue. So these are tissues from patients. These are leukocytes, immune system, and we have essentially two categories: ICU and non-ICU. And the same when we scroll to other, we have ICU and non-ICU. So basically, the experimental design for this GSE 157103 was that there were ICU and non-ICU samples from COVID and non-COVID patients. So we are interested in those COVID samples. So the idea for this exercise today is that I would like to show you how to get the list of differentially expressed genes from COVID patients when we compare ICU patients with non-ICU. So essentially, I want to know, or I want to show you how to know which genes are up or down regulated in those patients that end up being admitted to ICUs. When we have this information in mind already, we kind of know the experimental design, we then know more easily how to progress further. So which options to choose. So let's see, detail group, no, experimental category, that was. So when we mark COVID, then essentially, effectively, you can see that this number here on the lower left side, it's 100. So essentially, as you can see, this other samples are 26 of them. COVID samples we have 100, and that includes both COVID ICU and COVID non-ICU cases. So the next thing is that I want to go to the severity, and here I want to only mark those 50 ICU cases. Let's just even color by that so I can show you. So gray are non-ICU COVID cases, and reds are ICU COVID cases. So let's just mark those 50 samples right now, and here if you click this one, that will this button here with one, that will assign those 50 samples to group 1. So we do it. We can see that now in group 1 we have 50 samples, in group 2 we have 0 samples. So I instead of now ICU, I want to mark non-ICU cases. And again, the same, we have 50 samples, 50 plus 50 is 100. I click this. So now again, as you can see, we have those selections, and let's go for this button here, for example. It's like the first quick analysis that we can see. So this will calculate top 10 differentially expressed genes. For example, we get PRR5L. We can use that to actually color those samples that were like all of the samples, all 1000 that we have in CovidExpress, but especially those that were highlighted already here. So we can see kind of that, yeah, it looks that it's higher expression in non-ICU cases. So it would be, I suppose, downregulated. Yes, it's downregulated. Log to fold changes on the minus. So yes, this is a nice way to view all of that, but it's let's say not so global. So for some applications that might be enough, but usually I prefer to go with this option. There's a button on the lower right, which when we mouse over it, it will show us differential gene expression analysis between groups. So now we have those two groups assigned, right? So let's click it. The pop-up window is here. We have 100 samples. Groups are there. We just click those get DEGs. Now we have to wait a little bit. The more samples we highlight, the longer it takes. If we would have maybe 6, I suppose it would be much faster. Anyhow, so we have this. Nothing popped out, like except of 2 buttons, but so the data is there already. So we can click this button, plot volcano, which will show volcano plot in a minute. And essentially those plots that we provide in the portal, they are in SVG format. So this is like vector graphics, especially in terms of those volcano plots. Each dot here, each point is actually like an object line of the code in SVG. So you can view it, you can zoom it, and we can download this. As of now, when I'm recording this, it's October 8th, 2021. This download button at the moment doesn't work, but this feature will come in. If you want to save this file, this image, for a publication, for example, or any presentation or anything like that, just right click it and save image as, and then you can save in vector format. So just FYI. So what else we can see here? So this is classic volcano plot, which shows downregulated genes and upregulated genes. You can see different coloring. So the coloring is based on different thresholds. So the most stringent ones are those reds and like blues. So with fold change higher than 2 and FDR lower than 0.05. But sometimes, dependently on the question and so on and so forth, more relaxed thresholds are good to have. So we provide everything, and you as the end user can decide which one is the most appropriate for your particular case. So this is great representation of what's happening. On the other hand, many of the users would like to get the raw data for some downstream analysis, and you can easily get them with this download button here. So when we click that, we can open this, for example, with Excel. This is standard CSV, so comma separated value format file, and in here you have the genes, you have the log to fold change, adjusted p-value, p-values, and those categories that you have also seen here on the volcano plot. So all of the data is here. It can be easily used, for example, for some pathway enrichment analysis or anything really. So yeah, if you want, please leave the comments. I hope this video was helpful. If you had any questions or suggestions, what other features you would like me to show to you in format of this kind of tutorial, feel free to let us know. And stay safe. Bye.